Okay, this is the stoichiometry practice problems worksheet, and I'm going to be doing 2 problems at a time with this worksheet. So, for this one, lithium hydroxide reacts with hydrobromic acid to produce lithium bromide in water. There's our chemical equation right here. If you start with 10 grams of lithium hydroxide, so I'm starting with 10 grams of lithium hydroxide, how many grams of lithium bromide will be produced? So it's asking about lithium bromide, even though we're starting with lithium hydroxide. And it's asking how many grams. So we're going from grams of one compound to grams of another within a chemical equation. Before we start, let's make sure that our equation's balanced. We have one lithium here, one lithium here, one oxygen here, one oxygen here. We have two hydrogens, and one bromine. So we're okay with balancing. In order to go from one compound to another, however, we need to get it in moles first. So we're going to go from grams to moles, and we're going to do that by using the molar mass of lithium hydroxide. Then moles to moles. We're going to do that by using coefficients, which is also called the molar ratio. And then moles to grams of lithium bromide, again, figuring out the molar mass. But this time, we're going to figure it out for lithium bromide. So, before we get started, let's get all our conversion factors straight. Molar mass of lithium hydroxide. We have lithium, oxygen, and hydrogen. Lithium is 6.941, oxygen is 16.00, and hydrogen is 1.01. We're going to multiply each of them by 1, because if we look at our equation, we don't have any subscripts, we don't have any little numbers, which means that they're all 1. Which means that the lithium is 6.941 times 1. Oxygen 16.00 times 1 is 16.00, and hydrogen is 1.01 times 1. We're going to add all 3 of those numbers up in order to figure out the conversion factor for lithium hydroxide. And that comes out to be 23.951 grams of lithium hydroxide is equal to 1 mole of lithium hydroxide. We're going to do the exact same thing, but now we're going to do it for lithium bromide. So we have lithium and we have bromine. Notice that there aren't any little numbers. There's no subscripts, so that means that they're 1. So 1 lithium times 6.941 and 1 bromine times 79.90. And we found these numbers off the periodic table, just like these. We found these numbers off the periodic table on the left-hand side. So we're going to add these 2 numbers together to figure out the conversion factor for the lithium bromide. So it's 86.84 grams of lithium bromide is equal to 1 mole of lithium bromide. Alright, we now have all our conversion factors. The coefficients, we don't need conversion factors because they're just going to be the big numbers in front. Since we don't have any big numbers in front, they're all 1s. So we can take our starting point. That's where our arrows begin. So 10 grams of lithium hydroxide over 1. We have grams of lithium hydroxide on the top, which means I'm going to put grams of lithium hydroxide on the bottom of the next one. To get from grams to moles, we're using molar mass, which is right here. And look at grams, 23.951 goes with grams, and that is equal to 1 mole. So that's going to go on top. The grams of lithium hydroxide now cancel. We have moles of lithium hydroxide on the top, which means we're going to put moles of lithium hydroxide on the bottom of the next one. And now we're right here. We're going from here to here, from left to right, from lithium hydroxide to lithium bromide. In order to do that, we're going to use the coefficients. So if you look at lithium hydroxide, the coefficient is 1. And where we're going to is lithium bromide. So that's 1 as well. The moles of lithium hydroxide cancel out. We're now in lithium bromide. We've actually switched compounds in that bracket. So we have lithium bromide on top. So we're going to put moles of lithium bromide on the bottom of the next one, so that way the units match up and they can cancel. If we look here, here's moles of lithium bromide. 1 goes with that unit, and that is equal to 86.84 grams of lithium bromide, which will be on the top. So it's going to be 10. Oh, the moles of lithium bromide cancel. 10 divided by 23.95 times 86.84. That comes out to be 36 grams of lithium bromide. Notice every single time where we're coming from is always on the bottom. Where we're going to is always on the top. Okay, number 2. Ethylene, which is C2H4, reacts with oxygen gas to produce carbon dioxide and water. Here's our chemical equation, and it's already balanced for you. If you start with 45 grams of ethylene, so I'm going to put that underneath ethylene, the C2H4, just so I know where my starting point is. How many grams of carbon dioxide? So I'm looking for carbon dioxide and how many grams of it will be produced. So I'm going from grams to moles, because in order to go from one compound to another, I have to get it into moles first. Once I get it into moles, I can convert the compounds by converting to the other moles. And then in order to figure out the grams, I have to figure out the molar mass. So to go from grams to moles of C2H4, I need to figure out the molar mass of C2H4, which you find that out by looking at the periodic table. So we have carbon and hydrogen. You have 2 carbon and 4 hydrogen, C2H4. That's what those little numbers mean. If you look on the periodic table, you find that carbon is 12.01 and hydrogen is 1.01. So 2 times 12.01 is 24.02. 4 times 1.01 is equal to 4.04. To find the total molar mass, we're going to add these 2 numbers together. That's going to be your conversion factor to go from grams to moles of C2H4. Now to go moles of one to moles of another, that's when we use those coefficients. That's when the big numbers in front come in handy. To go to moles to grams of CO2, once we actually get, after we use the coefficients, we're going to use the molar mass. But this time we're finding the molar mass of CO2. That means we have carbon and oxygen. I look at the little numbers. 1 carbon, 2 oxygen. Notice I did not do anything with the big number in front. That's for the coefficients. That's only for this line in the middle to go from moles of one to moles of another. You do not use it for the molar mass itself. So 1 times 12.01, because that's the number on the periodic table. And then 2 times 16.00, because that's the number on the periodic table. We're going to add these numbers together. And that becomes our conversion factor to go from moles to grams of CO2. Now that we have all the conversion factors we need, we're going to go back and we're going to set up the conversion with our starting point. The starting point is the number that's actually given to you in the question itself. We have grams of C2H4 on top, which means I'm going to put grams of C2H4 on the bottom of the next one. And that's 28.06. That's equal to 1 mole C2H4. Grams of C2H4 cancel. Moles of C2H4 on the top, which means I put that on the bottom of the next one. And now we look at the coefficients. We're right here in our process. To go from here to here, we look at the coefficients. Notice that there is no coefficient for C2H4, so that becomes 1. We're going to CO2, so that coefficient is 2. So we have moles of CO2 on top, so that means we want moles of CO2 on the bottom of the next one. And that's 1, according to our conversion factor. 44.01 grams is equal to 1 mole of CO2. Those cancel. So this would be 45 divided by 28.06 times 2 times 44.01. And that comes out to be 140 grams of CO2.